And the other thing to say is just like observe that we're starting a bit late today. Wednesdays I can't really start anywhere near 9 o'clock. So I did want to get something up in the morning, but if this is a long or difficult problem, I may not have time to finish it before I go to bed, and then I'll just upload a second part later. But hopefully it's a fast one. I saw that Will Morgan's solution, I think, was fast. I'm not sure. Maybe he uploaded a two-parter. I didn't want to watch it because like it's spoilers, but I saw he had a video that was like 7 minutes long, but he might have also had another 45-minute video before it. Anyway, day 6, chronal coordinates. The device on your wrist beeps several times, and once again you feel like you're falling. Oh, that's right, it's been 5 days. We're going to go 500 years back in the past to the year 1018. Situation critical, the device announces. Destination indeterminate. Chronal interference detected. Please specify new target coordinates. The device then produces a list of coordinates. Are they places it thinks are safe or dangerous? It recommends you check manual page 729, which we don't have. Okay, great. If they're dangerous, maybe you can minimize the danger by finding the coordinate that gives the largest distance from the other points. Using only the Manhattan distance, determine the area around each coordinate by what? By counting the number of integer xy locations that are closest to that coordinate. Okay, so for each point x, I want to look at all other points that are closer to x than they are to any other point. Except for themselves, of course. Your goal is to find the size of the largest area that isn't infinite. The area around... Okay, so here's the visualization of these numbers. And so, like, here, it looks... What? So what points are closest to A? None, right? B, D, E, and C are all closer to like stuff in the middle. But so is F, right? Ah. No. It's not about comparing coordinates pairwise to each other. The largest area that isn't infinite. So we have an infinite coordinate plane, and we must select from it any point at all from minus infinity to plus infinity. And the constraint is... Well, no. Let's try again. Each point sort of radiates itself, you know, to... each destination radiates, like, itself in every direction until it meets a wave coming in from some other point, at which point they obliterate each other. And so extending off into infinity, like this C here is an infinitely sized area. There are an infinite number of points closest to C, and so this cannot be the correct answer. Likewise, A, B, and F are all infinite. But D is bounded on all sides by A, B, E, and C. In fact, C doesn't even have to get involved. Maybe here it does. Yeah, because this is distance 3 from D and distance 4 from A and E. So if it weren't for C, this point would be a D point. And here, I think it's clashing with both A and C. 4 away from each of them? Yeah. Or no, just C. Wait, so why doesn't this say C? Shouldn't this be C? It's just 3 steps away from C. 1, 2. Oh, Manhattan distance. Right. Right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. Wait, why doesn't this go to A then? Because it's tied with E. 1, 2, 3, 4, 5. Okay, that's weird. So D is actually not competing for this square at all. E is. E and A are fighting for it. D and C are both further, even though they look close because of Manhattan distance. Interesting. So having... Boy. Like, Haskell's good at dealing with infinities, but here I have to deal with infinities. I have to figure things, like, I have to reason about, like, what is even a good algorithm for this. Huh. So, I mean, you can try if you want, just okay, so here's a way to tell, I think, whether a point is part of an area that is infinite. And I think that's the only part that really matters. Like, once we determine that... I don't know. There might still be... You might still need to work with infinite areas some to resolve conflicts where, like, you know... Let's say we looked here and this was our first C point we examined. We would say, oh, you know, this is actually part of an infinite area. And therefore I don't care about C. But of course that's not true. We still need to know about the stuff to the west of C. Because it changes the shapes of D and E and A. But so my idea for determining whether an area or a point is in an area that extends infinitely is if there is any direction you can walk from that point that increases your distance from every destination, then you must be, like, since we're here, right? C is the closest and there are no ties. If there's any direction you can walk that increases your distance from everywhere, it increases it from everywhere by 1. And so C will still be the largest, right? It's not like it'll ever, like, get swamped by something coming up this way to catch it or something. So that's how we can tell if an area is infinite. But what do we do about that? Like, what still is the algorithm for computing what the finite spaces look like? I guess the other thing is that we can compute the bounding box of the points that we're given. And we just absolutely don't care about any areas outside of that, because those are guaranteed to be an infinite space, an infinite area, right? So... And any point... Wait. What was I thinking? I just had an idea. We've computed the bounding box. And anything past the edge is infinite. That's fine. And anything that is not past the edge has at least one direction it can walk in that makes it close. Like, I don't know. Let's go look at our input and like just get some ideas about what the scale of the problem is, I guess. So there's 50 points, and they're in the range of like, you know, like less than 1,000. They're less than like 500, right? The problem is that like how do you, like, what's a good algorithm for finding the closest point? You guys can't see this, pardon me. We have like 50 lines exactly, and they're all like small positive numbers. Well, between 1 and like 400. So what's a good algorithm for finding, like, okay, one thing we could do is just like, this is what, like 1.6, no, 16,000? 160,000. Yeah. If we just drew a 400 by 400 box, there would be 160,000 points. And for each one of them, we want to do 50 distance comparisons, right? More or less. And that's like 800,000? No. 8 million? Yeah, it's roughly 8 million distance computations. So, not great, but not completely outside the realm of possibility either. So it might be worth trying to find a better solution. Let's just look at, like, is there an algorithm for this? There's a set, the closest pair of points. Okay, this doesn't seem to be about the generic thing. Finding closest, no, nearest Manhattan distance between the point and line. What? Okay. Well, okay, I mean, I guess we can look at this closest pair points algorithm with Manhattan distance, but I don't think that's what I want. No answer to this question. Okay, so the other thing we could do that actually seems a lot more manageable is to do flood fill starting from each of the points in a breadth first way. Right? So, like, we start a frontier point that contains just all the points that are in the input. And then at each step, we walk in every direction from all of the points that we currently have and increase the distance by 1. And we'll eventually, like, and then we mark the area we landed in as belonging to the point we started from. And eventually, 2 of these steps will run into each other. And that'll let us start trimming the frontier we're working with. In that way, we just explore each point at most 4 times, right? Well, maybe more than that, because we'll like explore from E and we'll say go in all the directions, E, and we'll like go to here, and then we'll say go in all directions, and we'll like go back here, and we'll say, oh no, I don't need to continue that exploration, I've already been there. So we'll be sort of wasting time going back. But I guess we can have each point also store a list of directions in which it's reasonable to walk. And when you land on a point, you remove from that point's list the place you came from, because you already know the solution for that square. And then you just go in all the others. Yeah, but you do need to do that marking. Well, no, you don't need... When you explore a point, you remember where you got to it from. And then add the other 3 neighbors to your explore list. And remove your current cell from the eligible for exploration list. Right? That seems possible. And right. This, I think, is what I was going to say about the infinite areas. Is that an area is definitely infinite if you're walking away from all other points. And if you are inside of this bounding grid, you are never walking away from all the points. Right? You're always walking towards at least whichever one formed the boundary. So we can start from all of the destinations, do a flood fill outward, resolving conflicts when 2 fills meet each other. And then, once we've done that, we'll know that every area which includes at least 1 point on the edge is infinite, and all the others are not infinite. And then we can just do a frequency count of the points that were not on the edge. Right? And that'll give us the largest size. Okay, so I have an algorithm in mind, but there's a lot of details to get right. Okay, well, probably not going to finish this one tonight, to be honest. I mean, I stay up kind of late, but it's already kind of late. Let's get started writing some things, though, and we'll see where we can get to. Another point is like, geez, what even like machinery, what libraries do we need? I could imagine using like a mutable array here. It would improve speed quite a lot, I would think. To have this 2-dimensional array where I can modify entries. I'm not very familiar with using mutable arrays in Haskell, but I know it's a thing that exists and can be done using ST-array, presumably. Alternatively, we could use like a map from coordinate to data about the coordinate. Or, you know, a pair of an int map to data. That's also probably fine. and reasonably fast. Let's go back and look up Haskell ST array. What's the deal with that? Mutable boxed and unboxed arrays in the ST monad. Mutable boxed non-strict arrays. So what are the operations I get for working on arrays? Overloaded immutable array instance? What does that mean? I guess it's marray? marray is the type class for things you can do something with, whether they're boxed or unboxed, I guess. An array has type A, I, E, where A is the, I is the index, E is the element. Okay, so here's some functions. New array. New list array I don't much need. Read an element. So all of this is working within a monad, and ST should be fine, although... Do we need a monad transformer containing ST at the bottom? Are there any other monads I'm going to need here? Not sure. So we have read and write, which seem pretty clear. Map array, nah. Get bounds. And if we freeze it, okay, so an I array is an immutable array, I guess. Okay. So where do I even get ST from? Is it well, okay. Need to add some dependencies. It'll be interesting to work with ST, because I haven't done that before. And likewise, I've worked with arrays very little. So where does ST come from? It's in base, so I can just import it. Okay, and what are the operations on ST? It's basically just run ST, basically. Yeah. You can convert to IO if you need to, but we don't. All right, so we need array. All right, I mean, I don't know. Let's just make sure we can get the dependency. Yep, looks like it. All right. Well, let's... What are we going to have to do for part 2? Are we going to need to know what's furthest? I don't know. I guess it doesn't matter. We can just do the stuff we need to do and make it part of part 1 for a while, and then if it turns out to be useful in part 2, we can lift it out. So let's see. What? Data array ST. So we have run ST array. Oh, so we don't even need... Okay. So how do I make it? It's in marray. Sorry, here. All right, marray is in data array marray. And we have new array. Yeah, new array, okay. All right, I'm not sure the right way to structure applications that do this kind of stuff, but it'll be good practice, I guess. Let's import data.array.marray, and we want a few operations. New array, read array. We want write array. And we could thaw it, or freeze it, I guess. But I don't think we'll need to. We're just going to do a single run array and get the thing out. And the other thing that we need is port data array st run st array. And it returns an array, i.e., not an M array. An array is in data array. Okay. We probably need some other functions from here, right? List array, elms. Well, actually, like, maybe I don't need any of that stuff. Maybe I don't ever need to run the array. Maybe I can just call run st on something that gives me back the values from the array as get associates here. Yeah, maybe I'll do that. That's in data M array. So, given that, I don't seem to need run st array. I just need control monad st. Control monad st. And all I want is run st, right? I think. Is there anything else in here? Not really. So we'll basically have a computation running inside of st to allow us to use a mutable array, which needs to be inside of st. And at the end, we'll get out a list of all its mappings and return that as the result of our st computation. And then we'll choose the best point based on looking through that immutable array that we produce by mutably doing a flood fill, I guess. That's my rough plan at the moment. Okay. So the first big question, I think, is what is it that we will store in the actual array itself? At each index in the array, I need to store some information about how the fill has gone. So we need a data type here. I don't know, call it an info? Like, that's completely useless. I need a better name than that. data progress is progress. Record probably seems fine. And min distance is maybe an int, because we might have found the point before and we might not have. What else? Closest neighbors don't they do some weird... Haskell has some weird layout preferred for these things. Like, it wants me to do this. No, I don't really understand the Haskell style for how this stuff's supposed to go. I think it might be like this. Anyway, closest neighbors is a list of... We need a type for... do I want a new type or just a type alias for the... I guess it's going to just be an int, right? But I want it to be an identifier. So let's do a new type ID equals ID of int. So closest neighbors will be a list of all neighbors that are this distance away. If that list is empty, it will be because we haven't found anything yet. I'm kind of storing a little more here than I need, because like if closest neighbors will be non-empty only when min distance is non-nothing, right? So maybe progress should be a maybe of like the information that you got when you found the thing. But I still want some information here in all cases, right? Which is that I want, you know, a bool, which is like, is it valid for exploration? But again, that'll just be true whenever all this stuff is empty. And it'll be false when this stuff has anything written in here. So actually maybe the entire like progress data type should just be a new type, which is a maybe of an int and a list of ID. Sorry, it's a tuple of int and list of ID. I think this stores everything we could possibly want to know, right? When we look at a cell, if it's nothing, then no one's ever been there before, and we should initialize it with our current distance and add ourselves to the owner list. And we should also add its neighbors to the Explorer queue, right? Except the one that we came from. If we get to a node and it's not a nothing, then someone else has been there. The distance for it let's make this a distance. So it's clearer what the ID is for. If we get the distance that we see there will either be, I think, exactly equal to the distance that we're planning to put there, or it will be one less. It can't ever be more, and I don't think it can ever be two less, because we would have already explored, we wouldn't have been able to get there. So anyway, we'll look, and if the distance is less than the distance we were planning to put there, we shouldn't touch it at all. If it's equal, we should just add ourselves to the ID list and not do anything, right? Okay. So let me check what's in array again. So an array, well, marray is indexed by, wait, an marray A and A is the array type constructor. All right, go back. So st array has 3 type parameters, and these I understand. Right, I is index, the index type. S is a phantom we can't ever use, and E is the element type. This is all fine. My question is how this relates to right. Marray is the type of the type class of mutable arrays. E is our element type. M is the monad it will be embedded into, and A is the type st array, which has 3 arguments. Okay. I'm not totally sure I get it yet, but we're close. So, notably, where's my, is it not? All right, what's with this ix? Where is this? It's in base data.ix, so I need that as well. It's the type of indexes into arrays. What exactly do we need? We don't really need a range or an index. We just need like a tuple of ints, and that'll be fine. So really just the type class, the type itself will be fine. Oh, we don't even need that, honestly, because just a pair of ints is already ix, whether we import the type or not. And we never need to use it for anything. We'll just, the instance will get passed. Okay. So I don't think we need that. So let's make a little type alias for the array we'll be working with. It's a grid. Is an st array of s. Do I get the s parameter? Or is that a phantom that I never see? Data array st. I look at marray again. New array, provided that this type is an marray and this type is I, we pass it an index initialization element, and we get back a monadic value containing our array type. And A has an element type and a monad, and the monad is just st. I think. God, it's so confusing. Like, I think like using it should be pretty simple, but just figuring out what all the types mean is a little unclear. So st array, importantly, does not have an s in its type. Okay, maybe. Does it even, like, can I somehow get away with not saying what the type of this thing is at all? All right, let's actually try, I guess, just playing around in the REPL and seeing if I can even create a value of this type, and like, how do I do that? So what I want is from data array marray, I want new array 2 and we'll pass test as the thing to initialize it with. And I want the result as an st of m array int string. No. Oh, well, I didn't import st from here, so that's a problem. And I don't want m array. I want, oh, whoops, it needs a comma. I don't want m array. I want st array. And what are the type? St array takes 3 type parameters. I didn't import anything from data array st, huh? Because I decided I wouldn't need run st array, but I still need, like, make it to specify the types, I guess. So import data array st array. Expected one more argument. Yeah, I didn't say what type, what the phantom type should be. So how do I do that? Like, I can't get this. I can't get this out of st, which is fine. I just want to know what type it would have in st. Can I just say s and like have that be a vague unknown type? Expected one more argument to st of well, sure, this is the type. So like this. No instance for number int. Well, the type is not completely bonkers, at least. So this is a lot of work to avoid using a map, but I would like to learn how arrays work. new array takes an M array. Oh, this should be like so. Because st array. No, st array wants the s type first, then the index type, then the element type. So that was not the problem, right? And a pair of int is indexed, right? If a and b are indexed, then so is the pair of a and b. And int is indexed. Okay, what the heck is new array? New array, provided that the array type you have is an M array over E and M. Is it though? How do I make Haskell st array stack overflow? Okay, so I'm trying to figure out, like, so how do you make one of these fucking things? Ah. You have to specify right, not just the type. You have to specify the min bound and the max bound. Right, let's look at the type of new array to check. Yes, you have to pass a pair of I and I. Okay. So not just a size, but a min and a max, and it sort of like implicitly adjusts this for you. So let's say I wanted to go from 0, 0 to 2, 2. Oh my god, it's an ST action. I did it. And if I have this and I bind it to get elms, let's get a soaks. This should also, it should have the same basic value, which is that it's like an st action. And then if I next say run st on this, I should actually get back a list of nothings and their indices, right? Oops, come on. I did. Oh my god, I did it. I made an array with not nothings, but test. Okay. Cool. So what exactly is the right way to define a type so that I don't have to type this crap out all the time? I don't think it can be a type alias because this S phantom is pretty weird, right? But I can try, I guess. Let's say that my type grid equals this, right? And this does not work because S is not in scope. I can say grid S is this, but then I'd have to say like grid of S in all my contexts, I think. Also, why are you upset? You're not. Okay. So I could do that, but like this is for all S. So what if I say new type grid equals this? Is there an explicit for all I can enable somehow? Existential? Yes. Does that work or what? Can I parse data constructor? constructor I don't understand what that means. Does anyone else ever write these types out? Alias? They have an A. Okay, it would help to import that qualified, I guess, maybe. But now they have st array, and run st array. We specify it explicitly here. It looks like everyone just sort of writes that. That kind of sucks, though. Okay, well, what can you do? So I mean, it's like basically just this that we're copying around everywhere. I guess, you know, we can just make it the type alias and parameterize it, and then does that even work? I don't really want this wrapped in st. I just want this part, I think. And then I can have a function whose type is like, it's st of int, which will be my answer or whatever. Or st of s int. And then I'll use a grid s in that context. And that unifies those two types. I think that's right. So let's make a small milestone here and write a line of code. Well, for sure this would have been easier if I'd used int maps, but I'm learning. So what I want is a function that will take the input and pre-populate it'll just initialize the grid to say like closest distance for all these things is 0. There's an exception, right? Which is that we want to start exploring a point. Well, we can just have all the points initially be empty and just have, yeah, that's fine actually. And just have n exploration cursors, one pointing at each of those. And they'll explore it and say, oh, my distance is currently 0. Better add that myself to the list here. That'll be okay. So I was hoping to write a little function that would just like take our input and populate an array of them. But actually, we don't really care about the array itself won't be interesting. It'll just be full of progress nothings. So what am I doing? Okay. Another data type that we will need is a cursor, which is a cursor of distance, how far it's gone so far, and let's type coord equal int and a coordinate. And I wanted to also keep track of... No, that's fine. It doesn't need to know where it came from. We can just, when we're creating cursors, don't spawn one that's equal to where you just came from. I think you can do that okay. No, we'll just, well, we can just add one and like explore it and do no work. The frontier will be a little messier than it needs to be, but who cares? And we also need an ID, which is what space we're exploring when we started here, right? What space we came from that's getting us here. And honestly, like, I think I want containers because I want a set of points to explore. Is that important? Not really. I can just have a list, and there will be some duplicates, but each of them... Well, actually, if I have two cursors which each want to move to the same next place, and their cursors exploring the same thing, they'll get a little confused. So what I'm thinking is I want import data.set and what exactly do I need? I need a set, and like, what are the... What's in data.set, please? In containers, data.set. So how do you build sets? From list, of course. Sure. So I probably just need like the type set from list. And nothing else. I can do the rest with toList, basically. Okay. So we'll take data set and from list. Now these things start to need deriving ord, which is a bit annoying, but we'll put show in as well. Because we need to be able to sort a cursor, and a cursor has a distance, a coordinate, and an ID. So these, and like I might as well, although I shouldn't ever need to compare progress for equality, so let's leave that out. And now we need to restart Intero because we have new dependencies. Okay, fine. Jeez. Adding the code is a lot of work this year. I remember the early ones being extremely easy in previous years. And like day 6, sure, it starts to get a little tricky. But I guess like I sort of brought this upon myself by trying to use arrays in Haskell. But I wanted to learn how it works, so here we are. Let's just, okay, parse can return a list of a list of coordinate, right? That's useful, right? parse equals line, no, something composed with lines. Do I really need to bring parsec in for this? It seems completely overblown. No. Let's just actually, is there Haskell string split? Well, how to split a string? Are they gonna tell us to use span and break? Or import data list split, which seems kind of silly. Use drop while. Yeah, sure. I know you guys can't see this, but it's not that interesting. I mean, I think the thing to use is like span or break, and I always forget which is which, but they have the same type, but like one of them is take while and the other is drop while. Parse equals map parse line lines where parse line s equals case, well, span equal comma of ABC 1, 2, 3. So that's the opposite. I want break instead, right? Yeah. Case break S, or other order, equal comma of S of well, let's read, yeah, of X and comma underscore const to Y XY. No, this is not correct. Because now I have a pair and I have a list of two things and I want a pair. Whatever, we'll just be lame and say read X, read Y. Fine. So now, yeah, parse doesn't work because input is wrong. Like, I don't even want this stupid input type. I don't even want part 1 and part 2, honestly. But let's just, yeah, I guess I do, right? I just want type input equals list of coord, and like we'll just work with that. So now if I say parse 1, 2, 3, 5, I get back 1, 2, 3, 5. Which is correct. It's a list because we're pretending that was the whole input. Suppose that I instead say this. Same thing. Great. Now, part 1 of coords equals let actually, the idea of having an array that doesn't have 0, 0 in it is actually sort of compelling. So let's let I kind of want the minimum and maximum of both X and Y. So min X equals minimum by first chords, min y minimum, no, minimum map first, map second of chords, max x, max y, maximum map send chords. First of all, like this like friggin' stinks. I can write this better, right? Min x, min y, max x, max y equal do coordinate, no, order, let's call it compare, from the list minimum maximum, and look up from the list first second, pure comp pure comp map lookup chords, right? In undefined, is this type check? Yes. Okay. In run st of do. Okay, grid should be, how did we make an array before? New array min x min y, which I made capital, max x max y. Oh, I don't want new array exactly. I want like from list or something. No, I'm initializing the whole thing to empty. Okay, so it's progress nothing. Okay, and then I can just say how did I get stuff out of this? I bound it to something, right? Get a socks, get grid. Let's just make this return a string because I don't want to figure out what the right type is. We'll call show on it. Okay, what's wrong with this? New array. Okay, I do need to specify what type I want. That's true. Is okay, hang on. Instead of putting this do here, Why don't I just say run st solve this, right? Because I should be able to do everything based on, like, this is all I'm actually taking in. And then I can, like, write a function called solve, which is a function of type grid. Or no, it's a function of pairs of coordinates to st of, at the moment, string, but we'll fix that later. And solve equals do sts string. That's the important thing. We needed somewhere to put this s. Oh, but scoped type variables are going to be a problem now? Because otherwise it's going to be a different s? How the fuck does anyone work with st? This is, like, ridiculous. All right, back to Stack Overflow. st of s and st array. So if the type you're returning contains the s you're working with, you're fine. That you can just put them both here and then let it flow in via type inference. I guess the point is, it's fine if it's for all s, I think. So this is st of s and st array s chord progress. Oh, we already have our type, sts grid s, right? Also, it's really a pair of coordinates. No, it's not. Okay, what's wrong? Okay, that didn't fix it. So what's everyone so upset about here? New array. Oh, whoops. Solve of this. Oh, actually, bounds. I can just bounds. Okay, new array. I'm returning an st array what? An equation for solve, yeah, that's fine. In this expression, in a statement of a do block. So this expression claims to be an STS of grid S, but actually it's an STS of st array S1 coordinate progress. What's the difference between those things? It says string. Why would I write such a thing? Why can't I? Oh, my cursor's in the wrong window. Okay. Now, what are we upset about here? It doesn't know what monad to work in? Oh, of course. Because I need to say... it needs to know that it's in ST. Pure show SOX, right? And in fact, I could just do much better than this and say show mapped over this. Okay, cool. So this is not like close to being done. But I want to just like see if I got somewhere. Yes. We built an array of the right size containing a bunch of progress markers that are empty. And we did it using strArray. And now, inside of this context, I can perform mutation operations on the array. Boy, maybe I should have done some of this stuff off camera, huh? But I wanted to have something up. I just didn't think I'd spend an hour and 15 minutes on like learning how to build an array. Well, that's not true. It was only like 45 minutes. Because I spent 20 minutes just thinking about how to solve the problem. And then some more time on like actually typing code out once I had some ideas and figuring out how to model things and so on. So really only half of this video, at most, was on like how do I make an array. But I think that we are done for tonight. Let's just commit day 6, part 1, preliminaries. Learn to make an array. Parser, comma, learn to make an array. Hello, I can't type anymore. What have I done wrong? I ruined Bash. I hit XE or something. It just like went totally nuts, which nothing. Control C doesn't do anything. Control Z doesn't do anything. Oh my god. I can't even switch. No, yeah, I can. I can easily switch to my other window, and that's all fine. All right. How do I close a window again? Can I like search this? Close? I don't... Where am I? I did a search. Did it kill? No. Kill pane. What the heck? How do you close a window in Tmux? It can't be that hard, right? Tmux close window. Tmux cheat sheet. I used to have this like handy. Probably last year, I think, in fact. Sessions, window, ampersand? All right. Yep. So did this get committed? It didn't, right? But this is in my history. That's weird. Huh. Okay. Well, I won't push this now because whatever. So I don't think I'm gonna do all of this on camera. I'm gonna like work through this on my own later. And get back to you guys when I have something that looks okay for part 1. And give you a tour of what ended up happening. Because I think it'll still take a while, even now that we've done all this. Thanks for watching, and I'll see you next time.